Hi, my name is Samir Desai, and in this video, I'm going to teach you how to draw the formation of a carbocation. A carbocation is a positively charged carbon bonded to three other substituents. While the carbon is always positively charged, the substituents can be any molecule. But we'll usually see it attached to other alkyl groups, so it ends up looking like this. Carbocations are formed through one of two basic mechanisms. One way is ionization through the departure of a leaving group. Ionization is the process of a molecule acquiring a positive or negative charge. In the case of carbocations, the carbon acquires a positive charge. Leaving group is likely a new term, and we'll cover it in more detail when reviewing substitution and elimination, but it's a molecular fragment that takes both electrons from the bond when it leaves the parent molecule. The important takeaway from this is that a leaving group has the ability to create a carbocation. Another way a carbocation can be created is through the ionization through electrophilic addition to a pi bond. Electrophilic addition to the pi bond is exactly what it sounds like. Electrophiles are electron-deficient species, usually seen with a positive charge, that would love to accept a pair of electrons and become neutral. Although this is a simplified way to think of it, a way to understand this is the electrophile will steal the electrons from the double bond and attach to one of the carbons. The other carbon, having lost an electron from the double bond, will go from its previously neutral state to positive. The apply questions on the following slides will illustrate how hydrocarbons undergoing one of these two mechanisms result in a carbocation. Draw the mechanism that creates a carbocation through the ionization of a leaving group. Here, we have a central carbon bonded to three alkyl groups and one water molecule. Although it's not shown, the oxygen is positively charged. We mentioned earlier that a leaving group takes both electrons from the bond when it leaves the parent molecule. Remember that a sigma bond, like the one we see creating a bond between the carbon and the water molecule, is a way to show two electrons being shared. Since this oxygen is positively charged, it definitely wants to grab the electrons here. What we have left is a water molecule. It no longer has a charge because the lone pair of electrons balances out the positive charge. The remainder is a carbocation that looks similar to the original molecule, but without the water attached. Notice the carbon was neutral because there was a balance of electrons and protons, but when you remove the negatively charged electrons, this carbon is now positive. So, there you have the creation of a carbocation through the ionization of a leaving group. Moving on to the second way a carbocation is formed, let's draw the mechanism that creates a carbocation through the electrophilic addition to a pi bond. Here we have the electrons in a pi bond attacking the positively charged hydrogen, often referred to as a proton. This attack adds the hydrogen to one carbon in the double bond. We're left with the other carbon that was previously neutral, but since it lost an electron from the double bond, it is now a positively charged carbon. This is the creation of a carbocation. So there we have it. Now you should feel comfortable understanding how carbocations are formed. In the subsequent lessons, we'll cover carbocation stability and also how this charge plays a role in addition reactions.